What's up, folks? Welcome to Math Walkthroughs with Mr. Weeb. Today we are representing the addition of fractions. These are our Lesson 2 Your Turn questions. The first question is, estimate each sum. Explain one of your estimates. More of a demand than a question, really, but let's get right to it. First, let's look at 4/5 in blue and 5/5 in red. It's helpful if we consider our fraction strips right here that they very kindly put on this page for us. 4/5, if we look at it, is less than 1, but pretty close to 1, right? 5/5 would be 1, 4/5 a little less than 1. So I can say this. 4/5 is less than 1. Likewise, when I look at my fraction strips, I can see that if I have 5/8, 4/8 is half, and 5/8 is a little bit more than half. So I could say this. And if 4/5 is less than 1 and 5/8 is more than a half, then together they probably are approximately 1 and a half. Let's look at our next one, which says 1/4. And I'll just do this in case we need to go over this again. 1/4 and 3/5. Okay, 1/4 is, let's keep that as our benchmark, and let's consider 3/5 as 3/4. Right? It's fairly close to 3/4. And I can tell again by looking at the fraction strips. If I have 3/5, here's 1, 2, 3/5, it's pretty close to 3/4, which is right here, right? 1, 2, 3/4. And I can just compare them. Now, if it's close to 3/5, I know that it's going to be less. 3/5 is less than 3/4. So if 1/4 plus 3/4 is 4/4 or 1, then I can say that 1/4 and 3/5 is going to be less than 1, a little less than 1. So again, 1/4 and 3/5 is a little less than 1. Finally, let's look at 9/10 and 8/9. Well, 9/10, I hope we can see, 9/10 is going to be very close to 1, and 8/9, 8/9 isn't on here, but we should know that 8/9 is very close to 1, again, because we're just 1/9 away from being a total of 1. So for this, I could say something like this. Since 9/10 and 8/9 are very close to 1, adding them would be a little less than 2. Next it says, how could you model this addition? Well, I might model it like this. I've got a rectangle, and I'm going to show 2/3 in blue and 2/7 in red. Next, let's see what 2/3 would look like on here. There is my shape split roughly into 2/3, and here's my shape split roughly into 7ths. And I hope that we can see that this is a 7th, and another 7th, and a 7th, and then we can go all the way along here. They're all 7ths, and if we add them all together, we've got 7 7ths, or the whole thing would be completed if all of those columns were filled. And then along the rows, we've got a 1/3, and another 1/3, and another 1/3. So if we have 2/3, 2 of these rows filled up, and then another 2 of these 7ths filled up, we should have the whole thing full. So let's see what that looks like. Let's fill 2/3 with blue circles. So here we go. 2/3 are going to be blue circles. Here is 1/3. 2/3 full of circles. Next, we want to have 2/7 full of circles as well. So let's do this. There we go. There's 2/7. Now, it is looking a little bit crowded in specifically these squares up here, right? We don't want these guys sharing a room, so let's move these red circles down here so they don't have to share. And then we'll be able to see quite easily how much of this total shape is full. The way that we find our denominator is by counting the total number of spaces in this shape. So have a look. We've got 7 spaces, 14, 21, which is just 3 times 7, right? So our denominator is just 21. How many of those spaces are filled? Well, we can see that there's only one that's empty, so it's 20 out of 21 that are completely filled. Next, it says create a problem that could be solved by adding 4/5 to 1/2. I might say something like this. Packs of pencils come in tens. I gave out 4/5 of a pack yesterday and half a pack today. How many packs did I hand out in total? I will model this with a shape that is easily split into into fifths and a half. So the fifths might look like this, and the half might look like this. Now already, since I can see that my shape has a total of 10 spots, right? 5, 10, I know that my denominator is going to be 10. I just don't know how many yet. So to find out, let's fill these with circles. Okay, so first I'll fill it with blue circles. I need 4/5. So here is 1/5, 2/5, 3/5, 4/5. 4 out of 5 of these columns are filled. Then I'll switch it to red, and we'll fill half of the rows with, well, circular shapes anyways. There's a half. Now we've got too many circles sharing their spots. So let's move this guy over here, but we still have 3 left over, right? So we've got how many tenths? We've got 13 tenths. We've got 13 of them because each of these, this is 1/10, 2/10, 3/10, 4/10, 5/10. We could keep counting, but we would get to 10 tenths altogether in this whole, and we would have 3 left over. So this is 1/10, 2/10, 3/10. So 13 tenths in total. Or the better way to put it is instead of being in an improper fraction, the better way of doing it would be to put it in a mixed fraction, which is 1 and 3/10. And I would also have to put this in a sentence. I handed out 1 and 3/10 packs of pencils. And if you really want to make sure that you know where that answer is, it's a good idea to put it in a bit of a rectangle. It's kind of a messy rectangle, but it works. All right. How could you use what you know about 2/3 of 30 and 4/5 of 30 to figure out 2/3 plus 4/5? Well, how do we figure out 1/3 of 30? If we have 30 and we split it into 3 equal groups, that would be 10, right? Basically, we're saying 30 divided into 3 equal groups is going to be 10. So 1/3 of 30 is 10. And by that token, we also know that 2/3 of 30 would be 20. Okay? Now let's see what 1/5 of 30 would look like, right? If we split 30 into 5 equal groups, then we would have 6 in each group, right? Because 30 divided by 5 is going to be 6. So 1/5 of 30 is 6. And if we just multiply that by 4, right? If we have 4/5 of 30, right? 4 groups of 6 would be 24. Okay? So, knowing that, if I added those two together, 24 plus 20, because that was 2/3 of 30, right? If we look at this, 4/5 of 30 is 24, and 2/3 of 30 is 20. So we're just going to add the 24 and the 20 together, and we get 44. Now what does this mean? Since the whole was 30, that means that 2/3 plus 4/5 is going to be 44/30. Okay, and you can again put that from an improper fraction, and you can see, okay, how many times does 30 fit into 44? Well, it fits in once. With how many left over? We've got 14 out of 30 left over, and that is the final answer there. Then we've got, what is 3/8 plus 2/5? So here we have a shape that shows 3/8 plus 2/5. Again, let's make some circles, okay? So our blue circles are 3 out of 8, so we've got to fill 3 of these columns. There's 1/8, 2/8, 3/8. And now we've got to fill 2 of these rows. One row looks like this, and 2 rows looks like this. All right. Next, we just need to move some of these red circles out of the way so that they're not sharing a room. No sharing. Okay. Now, how many out of 40? I know that I have 40 because I know that since this is 5 and this distance here is 8, I know that the total area is 40. So the total is going to be out of 40. That's our denominator. And all I need to do is count how many dots are in here. And so let's just have a look. We've got 1, 2, 3 groups of 8, which is 24, 25, 26, 27, 28, 29, 30, 31. And our final answer is 31. Does this answer match any of the ones along here? Well, sure enough, it does. C matches perfectly. That's it for today. Thanks for watching.